Hi everyone, in this video I'm going to talk about how we calculate population density and use some modeling as far as shapes representing geometric figures. We'll kind of go ahead and get into it. When we're talking about density in general in your science class, when you learned about density was when they had the mass of an object and they divided it by the volume. So in science class you did density equals mass divided by volume, and it was talking about a 3D space. It was taking up a certain amount of space. So, like water displacement, how dense is an object, so on and so forth. When we're talking about population density, though, population density is kind of similar, but we're not going to be talking about three-dimensional as far as like weight. We're talking more so the number of people or the number of objects or animals or whatever divided by the area that they're taking up. So divided by the area of the space. All right. So all you're doing is taking the number of items and dividing it by the area of a particular space, or it could be the volume of a particular space, just depending on the problem. All right. So here we go. A park ranger counted 7 coyotes over an area of 25 square miles, right? So we want to know the population density of those coyotes. Well, if I have population density, it's the number of items, or the number of objects, the number of people, the number of animals, divided by the area. All right, so that means I'm going to have 7 coyotes. That's the number of people or animals or objects. So number of people, animals, objects, so on. All right, divided by the area, which was 25 square miles. All right, so I just do 7 divided by 25, and we find out that that is equal to 0.28. So there are about 0.28 coyotes per square mile. All right. Let's do another one. All right, so in this one, this metropolitan city that has an average of 60,000 people visiting in the park. During its peak season, okay, the park is 3.14 square kilometers, all right? So same thing. I want to know the population density of the people. So this one is a number of people. Remember it's number of people, number of objects, number of animals, all right, divided by the area. So I have 60,000 people, and we're dividing it by 3.14 square kilometers. So 60,000 divided by 3.14. So there are approximately 19,108.28 people per kilometer, okay? All right, next one. Okay, in a city, there are 5,000 geese that live there. The city is about 10,000 square miles. Sorry, this word got cut off. It just keeps moving around. All right, so thinking about the same thing. So population density, we're going to say it's the number of geese. Remember, it's number of geese, people, so on. Divided by the total area. So there are 5,000 geese. And we're dividing it by the area, which is 10,000 square miles. So we do 5,000 divided by 10,000. And we find out there are about 0.5 geese in that area for the square mile, in each mile, okay? Per mile. All right, so this one is kind of going back to a volume idea, general idea with mass. So it says 20 students report to math class after playing basketball and PE. Over the course of the next hour in class, each person produces 800 BTUs, all right? British thermal units. The classroom is 20 by 20 by 15. How many BTUs per square foot were produced? All right. So we're going to go back to that same idea of what you had before in science class. So density is mass divided by volume, right? So the first thing we need to figure out is we know there are 20 people there, and each of them can give off 800 BTUs, right? So it's 20 people, and each of them can give out 800 BTUs. So 20 people are giving out potentially 800 BTUs, because we need to find the amount of BTUs that are given out in total, right? So we have about 16,000 BTUs that can be produced by those 20 people. British thermal units. Because remember, we still release heat, like our body heat and so on. BTUs, not just in people, objects can have BTUs and so on. All right. Now we need to figure out the volume of this classroom. All right. So remember, volume, classroom, once again, is going to be pretty straightforward as far as shapes. It's like a prism. Okay, so just length times width times height. So 20 by 20 by 12. So 20 times 20 times 12. Okay, so 4,800. All right, and now we're just going to take the BTUs and divide it by the volume. So we're going to take 16,000 and divide it by 4,800. And find out it's going to be approximately 3.3 BTUs produced per square foot. All right. Okay. Last thing I want to talk about is just modeling of real world objects. This is very straightforward. A lot of times we have objects that look similar to geometric figures and their names. So with this, I just took a picture of just 3 objects, and we're just going to name them based off of what they could be comparable to as far as geometric shapes. So let's look at this first one here. Is this green container. All right, so think about your list of geometric shapes. As far as 3D shapes, you have prisms, you have cones, pyramids, cylinders, spheres, hemispheres. You have a whole lot of different shapes, right? So it's what does it model the most? What does it look like the most? Well, if anything, we know it has this lip on the container, but overall it's circular here. It has a height, you know, and the base is kind of circular. So we would say that this one could be modeled by a cylinder. All right. Over here on the side, I have this apple. So besides this little part down here on the apple, and just it's not a perfect circle, but it's close to one, right? So we could say this would be modeled by a sphere. Remember, sphere. Right. And the last thing I have here is this pencil case. All right, I had this pencil case right here. All right, and it's saying, well, what could it be modeled by? Well, looking at the front of it, like it's a rectangle. This part kind of reminds us of a rectangle, and it's 3-dimensional. So this could be modeled by a rectangular prism. Okay. So that's all for this video. Once again, population density and modeling, describing objects based on geometric figures. I hope this was helpful to you. Let me know if you have any questions or comments. Thanks for watching.